Hello student. Today I talk about the spectroscopy. So first of all, what is the spectroscopy? So it is the branch of science that deals with the study of interaction of matter with the light, or it is the branch of science that deals with the study of interaction of electromagnetic radiation with the matter. Now I talk about the electromagnetic radiation. So what is the electromagnetic radiation? Electromagnetic radiation consists of discrete package of energy which are called as photons. A photons consist of an oscillating electric field E, so that the electric field denoted by the capital E, and an oscillation magnetic field, so it is denoted by capital M, which are perpendicular to each other. Now here you can see that the magnetic field shown the violet color and the electric field shown the green color, so it is the perpendicular. Now I talk about the electromagnetic radiation. Some terms are involved in the electromagnetic radiation, like the frequency, wavelength. So what is the frequency? So it is defined as the number of times electric field radiation oscillates in 1 second. The unit of frequency in hertz, so that the 1 hertz is equals to 1 cycle per second. 1 cycle per second. So frequency is denoted by V or the mu. Now I talk about the wavelength. So it is the distance between two nearest part of the wave in the same phase, like the distance between two nearest crest or throats. So it is denoted by lambda. Now the relationship between the wavelength and frequency can be written as the C is equals to V into lambda. As a photon is subjected to energy, so E is equals to h mu. So hv is equals to hc by lambda, so that the V is equals to C by lambda. Here the white light is passed through the glass prism, and here observe the some colors like the violet, indigo, blue, green, yellow, orange and red. So here the violet color frequency is 400 to 420 nanometer, indigo frequency is 420 to 450 nanometer, and the blue color frequency is 440 to 490 nanometer. Then green color frequency is 490 to 570 nanometer. Then the yellow color frequency observed at the 570 to 585 nanometer. Then the orange frequency is 585 to 620 nanometer, and the last is the red color frequency observed at the 620 to 780 nanometer. Now, principle of the spectroscopy. The principle is based on the measurement of spectrum of a sample containing atoms or the molecules. Spectrum is a graph of intensity of absorbed or emitted radiation by sample versus frequency or the wavelength. So spectrometer is an instrument designed to measure the spectrum of a compound. Like the first is the absorption spectroscopy. It is analytical technique which concerns with the measurement of absorption of electromagnetic radiation, like the UV radiation is observed 185 to 400 nanometer, and visible is the 400 to 800 nanometer. Now emission spectroscopy. So it is analytical technique in which emission is dispersed according to some property of the emission, and the amount of dispersion is measured, like the mass spectroscopy. Now the interaction of EMR with matter. So EMR is the electromagnetic radiation. So first term is the electronic energy levels. At a room temperature, the molecules are in the lowest energy level. It is denoted E0. When the molecules absorb the UV visible light from EMR, one of the outermost bond or the lone pair electron is promoted to higher energy state such as E1, E2 and En, etc. is called as the electronic transition, and the difference is that delta is equals to HV is equals to En is equals to S0, where n is equals to 1 to n number of, then the delta E is equals to 35 to 71 kilocalorie per mole. So here first term is the electronic energy levels. Now I talk about the vibrational energy levels. So these are less energy level than the electronic energy levels. So the spacing between the energy levels are relatively small, like the 0.01 to 10 kilocalorie per mole. For example, when IR radiation is absorbed, molecules are excited from one vibrational level to another. For example, ground state to excited state, or it vibrates with higher amplitude. Then I talk about the rotational energy level. So these energy levels are quantized and discrete. The spacing between energy levels are even smaller than vibrational energy levels. So that the energy order is delta E rotational greater than the delta E vibrational and greater than delta E electronic energy levels. Now I talk about the Lambert's law. So first of all, the statement of Lambert's law: when a monochromatic radiation is passed through a solution, the distance in the intensity of radiation with thickness of the solution is directly proportional to the intensity of the incident light. So here let I be the intensity of incident radiation and x be the thickness of the solution. Then minus di upon dx directly proportional to I. So it is the intensity of light. So that the minus di upon dx is equals to ki. So k is the constant. Integrate equation between limit I is equals to I0 at x is equals to 0 and I is equals to I at the x is equals to 1. So that the ln I upon I0 is equals to minus KL. Okay. Then 2.303 log of I upon I0 is equals to minus KL. So log I upon I0 is equals to minus K upon 2.303 L. Here log of I0 upon I is equals to A, and A is the absorbance. Now K upon 2.303 is equals to E. It is the absorption coefficient. So that the final formula is A is equals to E into L. What is L? L is the path length. Now I talk about the Beer's law. When a monochromatic radiation is passed through a solution, the decrease in this intensity of radiation with thickness of the solution is directly proportional to the intensity of the incident light as well as concentration of the solution. Okay. Now here the I, what is I? Intensity of incident radiation. And what is x? So x is the thickness of the solution, and c, so concentration of the solution. Then minus di upon dx directly proportional to c into I. What is c? This is a concentration of solution. And what is I? So it is the intensity of light. Now minus di upon dx is equals to k into c into I. So k is the constant. So integrated equation between limit I is equals to I0 at the x is equals to 0 and I is equals to I at x is equals to 1. So that the ln I upon I0 is equals to minus kcl. Now 2.303 log of I0 upon I is equals to kcl. Same like the Lambert's law. Then the log of I0 upon I is equals to K upon 2.303 into CL. Here the log of I0 upon I is equals to A, and A is the absorbance, and here K upon 2.303 is equals to E. So E is equals to molar extinction coefficient. So that the final Beer's law formula is A is equals to E into C into L. Now the T is equals to I upon I0. What is T? T is the transmittance. So minus log of T is equals to log of I upon I0 is equals to A. From the equation, it is seen that the absorbance, which is also called as optical density of a solution in a container of fixed path length, is directly proportional to the concentration of the solution. Thank you. Thank you for watching this video. Please like, share and subscribe my channel.